Hi there, this is Kadar Teaches Stuff, and this is a continuation of the video I made last time about the review of the entire unit. And like I said, I'm going to be doing example problems to tell you how to apply the notes that I used last time and how to actually apply them to proper questions. And before I start off, I just want to remind you that I'm a student who's learning everything as it goes. And I'm not a professional teacher or a professor. So just wanted you to be aware of that. And another thing about this video is that I took it off till here, but then I'm still going to be doing example problems on mixed circuits, so that's a combination of series and parallel, of ladder circuits, and maybe something else if it comes up. But basically, for now, what I did, at least, is that I wrote down a couple questions which I feel cover basically the gist of the topic, and knowing these would at least get you to know 90% of the material pretty well. Like, there's in every topic that you learn, there's always going to be a couple of not trick questions, I can't say trick questions, but there's a couple of more difficult ones. But the 9 questions that I wrote down, I feel that they're the ones that if you know, you should know and understand the topic in general. So let's start off by reading the first question. So the first question says, how much charge passes through a cross-sectional area of a copper wire in 1 second if the current is 5 amps? Okay, so what we know is that this question is asking about, let's see, it tells us what current is, right? Because amps is current, so we know I. It tells us the time, because 1 second equals time. And now it's asking for charge. So, if we remember from, actually not remember, well, you should have memorized the formulas, but over here, if we look, I equals Q over T. Hold on, let me just focus this. I equals Q over T. So we have 5, which is 5 amps, which is I. We have T, which is 1 second, and so we have to find the Q. So let me solve it on this paper. 1. I equals Q over T. So let's substitute everything we know. 5 amps equals Q over 1. And now we just have to solve for Q, which is the charge. So basically, it would be, we take multiply by 1, which would make it 5 equals Q. And so Q, therefore, equals to 5 coulombs. Because remember, you always have to put the unit. So you see, it was pretty simple. All you had to do was basically just look up the thing and find out which question applied to it. So now let's read the next question. If a current of 80 milliamps, okay, see, this is like one of the few things which I found most people don't pay attention to. You have to look at the symbol. If it says amps, just think of it like, if you remember the length system, which is like kilometers, hectometer, decameter, meter, decimeters, and like that. So if you remember that, and there's many ways to remember it, there's like King Henry died Monday drinking chocolate milk, or many ways, but basically the concept's still the same. Milliamps is is like 1,000th of a amp. So we have to keep that in mind. But in general, we know that we have the current. We need to find number of electrons, and we're given time because 5 minutes is the time. But remember, like I said in the notes, time should be given to us in seconds. Time should be in seconds. So there's two things. We're given I and T, so current and time, but they're in different units. So that would be your first thing that you have to fix. So take the paper again. 2. So this is what I was talking about. Like really, like it could be kilometers, but in general, just have kids have dancing mothers doing crazy moves. And if you're like, it could be kilometers, kilograms, and this M is really the base unit, so you can't really put that. But in this case, it would be amps. And if you're not aware of this, basically it's like if you have 1 amp and then you go that way, then you move the decimal point and add a 0. So 1 amp equals to 10 deciamps, basically. So, ignoring that, now getting to the question, 80 milliamps. So we have 80. We're starting from here and going to this one, the base unit. So let's see. 1, 2, and 3, right? So 1, 2, and 3. Therefore, our charge is going to be 0.08 amps. And then the second part is 5 minutes. So we have to convert minutes into seconds because time is measured in seconds. So 5 minutes equals, well, 1 minute is 60 seconds. So times 5 equals 300 seconds. Right? So now we need to find the how many electrons pass. So looking at our notes, we know that if we want to find the number of excess electrons or just electrons, we would use Q equals NE. However, if you look at this question, we're not given a Q, and E is always a constant, so we already have E, even if they don't give it to us, but we're not given a Q. So if you notice, we are given I, like we found. This is I, and we're given T. So we can use this equation to evaluate for Q and then substitute it in here. So let's do that. So I equals Q over T. So 0.08 equals Q over 300. And solve for Q, so Q equals, and I'm just going to multiply 0.08 times 300. So that's 24. So that's 24, and that would be 24 coulombs. And now we use it in the next formula, which is Q equals NE. So 24 equals N, which is the number of electrons, multiplied by 1.6 times 10 to the power of negative 19. And that's the constant which E represents. And now all you have to do is 24 divided by 1.6 times 10 to the power negative 19, and you get N. Therefore, oh yeah, and if you're doing it on a calculator, make sure you don't forget the brackets, because that could really mess your answer up, and you would get points deducted. 24 divided by, so if you can't see it, I'm just writing this in the calculator. 1.6 times 10 to the power negative 19. Right? So 24 divided by 1.6 times 10 to the power negative 19. And then you press enter. And you get 1.5 times 10 to the power of 20. So that's your answer. 1.5 times 10 to the power of 20. And it doesn't really have any units, so we just leave it like that. See, once you know the formulas, everything becomes so much simple. That's why it's not hard. It's just a lot of practice. It's basically like math. A lot of practice and you can get it. So now question number 3. How much current is drawn by a television with the resistance? Oh, okay. So you see resistance. You know that's going to be important. So underline that. 40 ohms. 40 ohms. And it is connected across a potential difference. In case you don't know, potential difference is just another word or another way of saying voltage. So equals 120 volts. All right. So from doing this, what are we supposed to find? We're supposed to find the current. So we look at this, and we already know there's resistance and voltage involved. So resistance and voltage, and we need to find electric current. So we would use Ohm's law, which is R equals V over I. So question number 3. Question number 3. So from this, we have 40 ohms. So let's write that down over here. 40 ohms. And then we have 120 volts. 120 volts. Right? So that's what we're given. And we have to find amps or current. Right? We have to find the current. So using the notes, what we have to do is we use the formula R equals V over I and just substitute the values. So 40 equals 120 divided by I, and then that becomes 40I equals 120, and we just want to solve for I, so I equals 120 divided by 40, and let's do some mental math. This becomes there, 4, 8, 12, so that's 3 amps is the answer. So basically what we did is we started off with this because we found out that we need amps. We used the right formula, plug it in, and then just solve for I, and we got the answer 3 amps. Alright, so we're already done 3 questions out of the 9. So now question number 4 is a bit, now they're starting to get a bit harder. But it's nothing too much, so don't worry about it. A 7 ohm wire has a resistance. Okay, so before we even go on, we need to find out what the important stuff is. So if it's a 7 ohms, it's probably going to be important because ohms represent resistance. And it's in the correct measurement, so we can leave it as that. Has a resistivity of 3.0 times 10 to the power negative 2 ohm meters. Okay, so resistivity, if you don't know, from the notes we can look over here. Resistivity is equal to K, the letter K in our formula. So that is going to be important. So let's underline that and put a K right there. And the length, which is also important, of 0.7 meters. what do we need to find? We need to find the area. So, what we would do for a question like this is write down everything we know. So, R equals 7 ohms. Oh, let me just label that. R equals 7 ohms. K equals 3.0 times 10 to the power negative 2. Length equals 0.7 meters. And area is unknown. So from our notes, we know we have to use R equals KL divided by A. So let's write that down. R equals KL divided by A. So now we can just substitute everything in. So 7 equals 3.0 times 10 to the power negative 2. Length is 0.7. And area is unknown. So we just leave it like that. And then that becomes area. And I'm skipping. Okay, no, I won't skip the step. Equals 3.0 times 10 to the power negative 2. And then 0.7. Therefore, area equals 3.0 times 10 to the power negative 2, 0.7 divided by 7. So you see what I did there? I just divided and separated A. And then what we do is, I really wouldn't recommend doing that, all of that in one step, because it's known that, like, in my personal opinion, I make really stupid calculation mistakes because I try and finish it all in one term, basically. So what I would recommend is you solve this first, and most graphing calculators or even scientific calculators would have the answers key, so my technique would work. 3.0 times 10 to the power negative 2, right? So basically you do that, multiplied by 0.7. And you get, I don't know if you can see this, but 0.021. So 0.021 divided by 7. And then you just take 0.021 and divide it by 7, and you get 0.003. 0.003. So basically we solved for area and we get 0.003 meters squared. And that's all we had to do. And we're done with question number 4. Now the next question is question number 5. And it might seem like I'm rushing through this, but if really you don't understand, then like just try and like rewind the video and like look over it again, and maybe it might come to you that you like, maybe you just need to look at it a second time. And so now question number 5. Question number 5 is a 3-step problem, so A, B, and C. So a TV set draws 2.5, that's the current when operated on 110 volts. Oh no. Alright, so that's the voltage. So what is the power used? Alright, so from the notes, we know that power... Alright, what question was this? Question number 5. So let me just label it so it's not confusing. So power equals VI, voltage and current. So we know 2.5 amps is the current. 2.5 amps equals I. And V equals 110. So let's just substitute that in. P equals 2.5 times 110 equals, let's use our calculator, 2.5 times 110. And we get 275, and the unit is watt, or capital W. And that's all the first part asked. Now, if we look, the second part, if used for 7 hours a day, what energy would be used? Like, what is the energy in kilowatts per hour used per month? Alright, so there's many parts to this, but basically, if you remember from the notes, joules equals basically watts per second, and we want to get to kilowatts per hour. So to transform that, we would just divide, ignore this, we would just divide 275 by 1000. And the reason why we do this is because, here, let me draw it again, kids. And yes, this is for length, but the same thing applies. We're going from the base to kilowatts, which is 1, 2, 3, and that's the equivalent of dividing by 1000. So we get 0.275 kilowatts, right? Because we just divided the power by 1000 to get 0.275 kilowatts. And since we know from our notes, energy equals power times T. Right? So what we need to do is convert the time. They gave us the time as 7 hours. 7 hours a day. So that would be power is 0.275 times 7. And yes, I did say earlier that we should have time in seconds, but in this case it's okay to leave it in hours because the answer should be in kilowatts per hour, kWh. So you just multiply the two and you get 0.275 times 7, and you get 1.925 kilowatts per hour, right? And that's in 1 day, per day. We want it for it says over here the question says per month, and I know a month could be a 30 or 31 days, but let's just say it's 30 and just do 1.95925 times 30, and you would get 57.75 kilowatts hour per month. Alright, so that was B. And finally the C. It says the cost of the TV is 10 cents per kilowatt, right? And how much, I forgot to write it down, my mistake, but how much of it is used per month? So if it's $0.1, right? Or like it depends on how you want it. I like to keep my answers in dollars and not cents because cents can get really big. So let's just say 10 cents equals to $0.1 times 1.92, times 57.75. And that's the answer we got from this part because that's how many kilowatts it takes. So 0.1 times 0.1. And we get $5.76 because you would have to round up in this case. No, it's 78. You would have to round up. You can't leave it to 3 digits because cents only go up to 2 digits. So 5.78. And we're done that. So now the next question. Alright, so that was it for electric current and electric power. And the next video we'll talk about, because the length is getting really long, I have to kind of chop it up. And actually no, I'll just try and fit it all in this one video so you don't have to keep on going and altering between videos. So let's go. Question 6. What is the current and voltage across each resistor? If you notice, this is a series circuit. If you don't see any branching, then it's directly a series. It just goes straight. And from that, we know that these are the resistance. And what was that one interesting thing about series circuit? If you remember from the notes video, it's that the current always remains the same. So the current, if you find the current for one, that's going to be the current for all of them. And how would you find the current for the thing? You might ask. You find the Req. So Req equals R1 plus R2 plus R3, because there's three resistors. R1 is 5 ohms plus 10 ohms, which is R2, plus 15 ohms. You get 15, 15, 30 ohms as Req. Using that, and then we use I equals V over R, which is just the remodeling of R equals V over I, and we get V is 15, Req over 30, and we get 0.5 amps. So, because we get 0.5 amps, we know that this is 0.5 amps. And the interesting thing about series circuit is the current always remains the same. So we can just write 0.5 amps, 0.5 amps, and 0.5 amps. And now simply, we just solve for voltage. So voltage equals I multiplied by R. So let's see. The voltage for the first one, 0.5 times 5 is 2.5 volts. So let's just write that. 2.5 volts. Then for the next one, V2, 0.5 times 10 equals, and if you just know, that's just like making it into half, so 5 volts. And for the third one, 15.5 times 15 equals 7.5 volts. So I kind of rushed through that one, but basically what you would do, always, like if you see a resistor, always find the Req first. Using the Req, find the current, and then that current, if it's a series one, is going to be the same in all, and then use that current to find the individual volts. So that's question 6 done right then and there. Now, question number 7. First part, A. What is Req? Well, we can use our original formula, which is, well, not original, but the normal formula, I really don't know the word for it, but we can use the formula we've been given, which is 1 over Req, R1 plus 1 over R2, but that takes a lot of time, and we can get the same answer using the inverse function. So let's say, just to show you one, so let's say if it was 1 divided by 40, 1 divided, you see 1 divided by 40 gives you 0.025. However, if we did 40 inverse, and that's like the x, it's this sign right here, you get the exact same thing. So using this, we can reset the equation as Req inverse equals 40 inverse, because that's R1, plus 40 inverse, because that's R2. So 40 inverse plus 40 inverse. 40 inverse plus 40 inverse. And then you get 0.05. And that's not REQ, that's the inverse of REQ. So what we would do is take the inverse of the answer and we get 20. 20 is the REQ. So basically what you do is that. Now part B. The entire... See, they're splitting up into steps, but really we would do this anyway because this is what you have to do for every single thing. And it should just come as second nature to you. So I equals V over REQ. You should have this formula memorized because it's like really, really important for circuits. We don't know I, but we know V is 40 volts and REQ is 20. 40 divided by 20 is 2 amps. And then using that, we can do the rest. So which 2 amps is in the entire circuit. So the current across each resistor would be, and like I said, the important thing about parallel circuit is that the voltage remains the same throughout. So it would be 40 volts over here and 40 volts over here. So let's just call this R1 and R2, right? These are the resistors respectively. And in this particular question, I'm just going to treat them as one because they have the exact same value. So I equals V over R. V in this one is, well, it's supposed to be 40 volts. 40 and resistance is 40 equals 1 amp. And I2 would be V2 over R2, which is the same thing, 40 over 40. And that's it. That's how you would solve question 7. Alright, I know this is a really long video, but we're almost done. We solved everything, and this is basically all you would need to know, and you could use this, what you just learned from this, and complete the rest, and you should be able to do fine. But I just wanted to put 2 more examples of mixed circuits and of ladder circuits. And I hope I can finish it in a few minutes now. So this is the diagram that they've given us. Find the current and voltage across each resistor. Alright. So the first thing you do is find the REQ. This, if you notice, is in series, right? Because there's no branching off. And when I say in series, I only mean from this end to this end, not the entire box. So if it's in series, you would do 4 plus 2 equals 6. So just for now, only for now, for finding the REQ, just pretend that this is 4 plus 2 equals REQ, and that becomes 6. Then now, this and this are parallel. So you would do 6 inverse plus 8 inverse equals REQ inverse. Using our calculator to do 6 inverse plus 8 inverse equals that big number, and we want REQ, so inverse of that, and we get that big number. We can round it off to, so REQ of this is 3.43, right? We get 3.43. And now just treat this as series again. So 6 plus 3.43, because this resistor and the REQ of the loop, 3.43, is 9.43 ohms. That's the REQ. Using that, we're going to find the current, the total current. I equals V over REQ equals voltage, 20. REQ, 9.43. Using a calculator, 20 divided by 9.43, we get 2.12, and that would be amps. Alright, so if we treat this as a series circuit, what do we know? The current's going to be the same, so we can write 2.12 amps over here, because the current just goes the same. Only for this, not for these. There's a different way to do that, which I'll do